Today we're going to solve equations with fractions, so fractional equations. I've broken this lesson up into 3 parts. So today we're doing part 1. This is where we see proportions. So anytime you are solving fractional equations, you always want to try to get rid of all of the fractions. So no matter what kind of equation you have, that's usually my first step. When we have a proportion, usually cross multiplying is the easiest way to go. So I'll show you that way. When you cross multiply, you have 2 fractions that are equal. You want to make sure at the very end when we get our answer that we do not have any fractions that are undefined. What that means is when we get an answer, we want to make sure that when we plug it in, it doesn't give us 0. And we'll see that when we do an example later on. So for the first one, it says to solve for x. So we are cross multiplying. So I'm going to maybe multiplying these 2 and these 2. So I'll show a little bit more work just so you can see what I'm doing. So I'm going to multiply x plus 1 times x minus 6. That was the first loop. Then I'm going to set it equal to the other one. So that was 2 times 2 minus x. Now what we're going to do is we are going to get rid of the parentheses and see what we get from there. If I was to multiply this with the boxes to speed up just this little part, when I do the boxes, I would get x squared minus 5x minus 6. On the other side, if I distribute, we would get 4 minus 2x. Now, because we have a power of 2, we want to get it equal to 0, so we're going to move everything to the x squared side. So I'm going to subtract 4 from both sides, and I'm going to add 2x to both sides. That means the 4's and the 2x's cancel out. So our new equation, we have x squared minus 3x minus 10 equals 0. I look for a GCF. There isn't any, and there's a power of 2, so maybe I can factor it. So I'll try that first. 2 sets of parentheses, x and x. Factors of 10 that subtract to give me 3 would be 5 and 2. We want a negative 3, so that would be 2 minus 5. So 2 is positive, 5 is negative. Now I'm going to go ahead and do the easy part. I'm going to split these up and set them equal to 0. If I solve them, I get x equals 5 and x equals negative 2. Before I circle them, I want to go back to my fractions and see if I plug these numbers into the bottom, if it would make it 0. If it does, it won't work. So if I take 5, 2 minus 5, that's negative 3, so that's okay. 5 minus 6, that's negative 1, so that's okay. Now I'll try this one. 2 minus negative 2 is 4, that's okay. Negative 2 minus 6 is negative 8. So they both do not equal 0, so they are both the answer. On the second one, we have our loop. We're going to cross multiply. So I'm going to multiply x times x minus 2, and I'm going to multiply 8 times x minus 5. All right, so now if I distribute, we have x squared minus 2x equals 8x minus 40. Again, because we have a power of 2, we're going to set it equal to 0. So I'm going to subtract 8x from both sides, and I'm going to add 40 to both sides. 8x's and 40's cancel. So we have x squared minus 10x plus 40 equals 0. There is a power of 2. I have it equal to 0. So now I look for a GCF. There isn't any. So I'm going to try to factor it. X and x. Factors of 40 that add up to 10. There are none. So we cannot factor. So what do we do when we have to solve and we have a power of 2? We're going to do the quadratic formula. Remember that formula? Negative b plus or minus. And then the rest of it, I'll put it down in a second. So in order to solve this, I have to figure out my a, b, and c. My a is 1, my b is negative 10, and my c is 40. So now I'm going to do the quadratic formula. I'm going to put it up here. I'm going to cover this up for just a second. I want to make sure it's on my paper. All right, so there's our formula. Now we're going to plug in our values. So instead of negative b, we're going to put negative 10, or just 10, plus or minus. Underneath the radical, we're going to have negative 10 squared. I'll move this over a little bit. minus 4 times 1 times 40. That's all on the top. All over 2 times 1. Now I'm going to simplify this, so we have x equals 10 plus or minus. If I do underneath, we have 100 minus 160. I'll show that just so it's on our paper, over 2. Now we have x equals 10 plus or minus negative 60 under the radical over 2. When we factor this, let me use my different color. I'm going to simplify this. I'm going to take out a negative 1. This ties into our radicals chapter, our complex numbers. Perfect squares that go into 60 would be 4 and 15. So that means I'm going to change the square root of negative 1 to I, the square root of 4 to 2. So now we have x equals 10 plus or minus 2I radical 15 over 2. Almost done. Is there something that we can take out of all of the outside terms? Yep, a 2. So that becomes a 1. That becomes a 5, that becomes a 1. So my final answer, x equals 5 plus or minus I radical 15. And if I was to plug this in on the bottom, it definitely would not give me a 0. So that is my answer.